Financial Modeling, Topic 20, NPV, IRR, and Other Investment Rules. Section 4, we're going to compute the Equivalent Annual Cost, EAC, and understand how it's used to evaluate projects or investments. So let's think about an investment in a project which have unequal lifespans. For example, say your business requires light bulbs. And you can either get this cheap incandescent light bulb or this expensive fluorescent light bulb. Now, what we're going to show you is this light bulb that lasts only about a few months compared to this one that lasts about 40 months. You can't really use NPV to compare two projects that are mutually exclusive in this case. So what we're going to do is we're going to spread the costs or compute the costs on a periodic basis and then compare them. So let me show you why NPV is not working. So if you look at the cash flows up here, and what you see is that an incandescent light bulb costs $1 today and lasts about 4 months if it's on for about 8 hours a day. And electricity, that 100-watt incandescent light bulb has the electricity of about $2.50 a day. So let's forget taxes, make this easier. So I'd spend $1 and I'd spend $2.50, $2.50, $2.50. If I took the NPV of those cash flows, and I'll go to the spreadsheet, the NPV of those cash flows using a discount rate of 8% per year, or 8% divided by 12 per month for 4 months. 8% of the cash flows, adding the first payment of $1 today. The NPV of one light bulb is $12.80 negative. However, what if I bought this fluorescent light bulb? I'd spend $5 a day, $5 to buy the light bulb. Now this cost here is a little bit different. This 100-watt light bulb, incandescent light bulb, has the same amount of light as a 15-watt fluorescent light bulb. So I got about 15% of the electricity to run this light bulb. So I just put in 45 cents as my cost to run this light bulb each month. Also, this expensive light bulb lasts for about 40 months. So if I calculate the NPV of this fluorescent light bulb, I take the present value of the monthly cash flows at the monthly discount rate, add back the initial negative $5. So in NPV terms, it's more expensive to buy a fluorescent light bulb than an incandescent light bulb. However, these are mutually exclusive projects, so we can't really compare them because this one lasts for 40 months and this one lasts for 4 months. So how am I going to solve this problem? Very simple. There's a little tool called an EAC, equivalent cost. And what I'm going to do is use a payment function, just like I did on that last loan problem I did. I'm going to put in the periodic interest rate. That's going to be 8% divided by 12. I'll put in the life of that project, 4 months, and put in where it says where it says present value, I'm going to put in the NPV of the light bulb. So there's my minus $12 for that incandescent light bulb. And this is going to convert it to a monthly payment. So the NPV of $12.80 is equivalent to a monthly payment of $3.25. And if I did the same math for this problem, this fluorescent light bulb, over 40 months with an NPV of 20, it has an equivalent monthly cost of 59 cents. So what you'd see is we convert the NPVs to a periodic cost using the payment functions. And the advantage of the payment functions is that it does account for the time value of money. And we see that it's clearly cheaper to replace the light bulbs using fluorescent lights. So in this project, we calculated the equivalent annual costs for projects of unequal lifespans.